Welcome to 2.1 Guided Notes about counting methods. So, a sample space is a list of all possible outcomes. Possible outcomes that can occur. So, when we're talking about the lottery, you got like a 1 in 7 million chance in winning, right? The best way to go through this, and it's not 7 million, it's more like 787 billion. Anyway, example 1. Your young cousin orders breakfast at a restaurant. The restaurant has two choices of milk and apple juice. The restaurant also has 3 choices of meat: sausage, bacon, and ham. Suppose the child orders 1 drink and 1 type of meat. Give the sample space that shows all the different outcomes for what your cousin might order. So we're going to abbreviate some things here. We're going to let M stand for milk, A stand for apple juice, S for sausage, B for bacon, and H for ham. Now, when we talk about how many choices we have, let's start with 3: sausage, bacon, and ham. And you wouldn't really know this unless you saw it once, But if I leave that top spot up there free, you're going to see what happens here in just a minute. Sausage, bacon, and ham listed down through here. Then that leaves me 2 columns for drinks, and I have M, which is my milk. And then I have my apple juice. Still can't write. Yeah, stick with me on that. Apple juice, and we're going to put A for that apple juice. So I can pick milk and sausage, milk and bacon, milk and ham. Or I can pick apple juice and sausage, apple juice and bacon, apple juice and ham. So if I count the results, each one of these is a possibility. There are 6 possible plates I could order. Possibly, 6 different plates. Okay? Just keep on rocking here. Example 2. A dart player is trying to hit the bullseye with each of 3 darts that he will throw. Each dart will either hit the bullseye or miss the bullseye. Pretty obviously, right? You're going to hit the bullseye or you're going to miss it. Use a tree diagram to give the sample space for the different outcomes that may occur. So, he's going to throw 3 darts. Let me show you how this works, because a lot of people don't see the tree diagram, okay? But he's going to throw dart 1, dart 2, and dart 3. Then he's either going to hit or miss. Hit or miss. Hit or miss. So this sample space is what we call a tree diagram. And it's really just the list of all possible outcomes. And if you wanted to list them so that you got that, you'd have dart 1 hit, dart 1 miss, dart 2 hit, dart 2 miss, dart 3 hit, or dart 3 a miss. And that's what it would look like, a list of all possible outcomes. Now we're going to what is called the fundamental counting principle. which says if I want to find the number of outcomes, this is possibles, for a given situation, I simply multiply the number of outcomes, these are compound events, outcomes for each individual event. So 2 drink choices times 3 meat choices times 2 egg choices. So I added 2 more things in there to pick from. I can draw that like this, or I can understand that it's 2 times 3 times 2. 2 times 3 is 6, times 2 is, so I have 12 possible meals I can make by just having 2 different drinks, 3 different meats, and 2 types of eggs, like scrambled, fried. The definition of permutation means that there is a specific order to our arrangement. A good question that you ask yourself when you're trying to figure out if it's a permutation or not is, does order matter? If the answer is yes, then we've got this wonderful formula for a permutation.